Well, hello everyone. In this tutorial, I'll show you how you can create circular motion in PICO-8. But before then, let's look at the theory that's behind this. Once we can understand that, we can use any programming language to simulate circular motion. So now let's start with a circle with a center point. So I'm just going to create a dot here and see this is the center of my circle, just right here, this red dot. So that is where my point is. So I have an X and Y position here. And with this point, what I'll do is just to draw my coordinates. So I'll just go over here and draw a line like that to pass through that point. This is going to be our Y axis. And then I'll go over here and draw another line to make sure it cuts through that center point. So again, this center point is just an offset. It could be anywhere. And what I mean by that, and this is X, actually that's negative X, and this is positive X. So I'll just do the X here. So what I mean by that offset is it could be here or it could be here. So our coordinates could be either here or here, and we can draw a center point like that at that point, or we could have something like this at this point. So now this center point, this CX and CY is going to be different. Now we need to, a circle has a radius, right? And it's the radius that will determine the width of that circle. For example, here we have our center point right here, and then it's our radius R, which is just over here, which is our R. This determines the width of the circle. 2R, that's our diameter, that's how wide this is. Now, we have, I think I could just use this one here. So if I draw a line here, that's not really, that's not neat. So if I draw a line here, like that, at this point, at this instance right here is going to be our X, comma, our Y position at that instance, because if you notice the circle is going round and each point our circle is moving, it has an X and Y coordinate. Now let's head back to this one. So I'll just go ahead and draw a circle, just a large one like that. It's not perfect, but I like it. It's good. And let's draw a radius like so, this point here. Right. So if we use dotted lines to complete this, let's say just use dotted lines here, and we also move that, let's say we have this other radius going here, and we use a dotted line to sort of pick this point. Then what we actually have here is, you notice we have this R, and we also have this R here. So the R is not really changing because that's what's drawing our orbit. Here we can have an angle, call that angle alpha. And what we can notice here is we can complete this to create a right angle triangle. Right. So using trigonometry, if we want to find, and again, this is our P, this point here, P, and our P is going to be our CX, our center X position, and our center Y position. That's our center. That's where this circle is orbiting. This is our center point. Now, we're going to have our R using trigonometry as it's going to be R cos alpha and R sine alpha. So our opposite for R, let me just draw out this triangle separately. So let's say we have this point, and I'll just change this color. So let's say we have this side, and then we have this side, and then we have the base. So let's use green for the base like that. So our adjacent at this point, if this is our X, comma Y, right? And this is our R like that. So our opposite is going to be R sine alpha. So opposite is R sine alpha, right? And our adjacent, I'll just use A, is going to be equal to R cos alpha, like that. So opposite R sine alpha, adjacent R cross alpha. These are exactly the offsets we are actually using to, find the path of this circle as it's moving along this axis. I hope that's not really confusing. So we have it here. At this point, we have it here. So if we are trying to find the x component of this, so our x is going to be equal to our center, which is our center x for this. So we're going to add that to cx equals cx plus r cos alpha, and then our y is going to be equal to our cy plus r sine alpha. And one thing I want you to note is our x component is always horizontal. So x is always horizontal and the y component is vertical. All right, so with that being said, let's jump into PICO-8 and begin coding to see how we can create a circle at that center position. And then once we have that circle, we're going to increase our circle each step, because every frame PICO-8 is drawing this circle. And as we are increasing the angle, so basically what I mean is our angle here, alpha, is going to be increasing each frame like that. So like that, as our frame keeps updating. So we have another alpha here, alpha 2, so we have alpha 3, and we have alpha 4. Basically, it just keeps increasing as we're going around. And since this is a unit circle, our sine and cos alpha will either be -1 or 1. It won't go beyond that. That's why we have this rotating around this point. All right. So with that done, what we're going to do is to open up PICO-8 and start coding. So first I'll just switch blink and hide that. And let's head over to PICO-8. So first thing I'll do is hit escape and I'll delete everything. And let's clear the screen because we're seeing some stuff here. So I'll just close this to get rid of the screen. All right, so let's add a comment and just say circular motion in PICO-8. And we're going to be using our parametric circle. So we're going to say x is going to be equal to our center x. And I want this to be a comment. So I'll just use these two dashed lines to make everything a comment. And we're going to add that to our r multiplied by our cos alpha. And the same thing for y is going to be equal to our center y. Add that to our radius multiplied by sine alpha, which is our vertical and horizontal components. So the first thing we want to do is to initialize our variables. And to do that, let's do that in the init function. So I'm just going to say function, and let's keep this here. I think it's super nice anywhere. I think that's good. So function underscore init, like that. And I'll just say end here. And what do we want to do? So this is where we set the center of our circle. Now PICO-8 is, the screen is 128 by 128. So half of that is 64. So we want a circle with a point at 64, 64 at the center of the screen. So to do that, I'm just going to say cx equals 64 and cy equals 64. Now we can do this like this, or we can use this style I like. So I'm just going to say cy is equal to 64, 64. That means cx and cy are both 64. The reason why I'm doing this is just to save token space, because PICO-8 has a minimum of 8,192 token counts, but we're not going to be building an app that has that number. So R is going to be our radius. So let's set that to, I found 40 works. And our angle, we're going to start from a flat angle, 0. And we also want to use an angular speed. Basically, that's just telling us how fast the object circle is going to be moving, right? So that's what omega is going to do. And omega is simply used for our frame update. So I'm just going to say omega, and I'll set that to 0.1. So we have our omega, and let's also use the concept of delta time. And I'm going to set that to 1/30. Now, PICO-8 runs at 30 frames per second, and a frame simply means it's like a flip book. Let's see if I can bring back Blink and show that example here. So let's say we have a nice little flip book like this. I think I'll use the space in. Let's use the space here. So let's draw this. So let's say we have one page of a flip book, page 1, page 2, and we have page 3 like that, and we have page 4, page 5, all up to page 30. So dot 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 dot, and this is the last page. And let's see, on each page I have this nice little circle here. So this is frame 1, but on frame 2 my circle has moved slightly up a little bit, and on frame 3 my circle is now here. On frame 4 my circle is up here at the top. At frame 5 it has now moved to the right side. So every second this runs 30 times. So 30 times. So if I want to know how many seconds each frame is running for, I'm going to say 1 divided by 30. I think that should give us, let me run the calculator. I think that should give us a value of, let's see, I think 0. Oh, I need to switch back to this. So 1 divided by 30. So that's going to be 0.0333, like that. So we're getting 0.0333. That means we multiply that by 30. It's going to give us 1 second. So each frame, we're actually moving at 0.0333 per frame. So if that's the case, then the time for 30 frames is going to be 1/30. That's 0.0333. And that's how we're going to be moving our circle. So that's why we have that delta time over there. And now, just like in our flipbook, our function update underscore update, I wish they called this flipbook. If I have my game engine, I'm going to call this function flipbook, because what it's doing is running every frame, 1 of 30th or 1 of 60th or 1 of 120th frames per second. It's doing that. And I think I should call the I should call this FPS, frames per second, because it's basically measuring a change between time. So I'm going to call that FPS. Now our angle, so our angle is going to increase by omega every frame. And to calculate that, we'll just say our angle is going to be equal to, or plus equals to, omega multiplied by our FPS. Now, instead of saying angle equals to angle plus omega multiplied by FPS, this is a shorthand. It prevents us from repeating angle again. So each time you see plus equals, you're just saying, hey, angle plus equals omega multiplied by FPS, without repeating angle again. So it depends on which style you want. Now, to draw anything on the screen in PICO-8, we need to use the draw function, which is very great for formatting shapes on the screen. So I'm going to say function underscore draw. Now, believe it or not, we're actually done with our modeling. So all we need to do now is just compute our position. So I'm going to send end here. Right, so first we need to clear the screen. So I'll use CLS to clear the screen to ensure that we're not drawing, our last frame is not drawing on top of our image, or else everything will look very smeared. I'll show an example of, what happens when you don't use CLS. You have something that looks very smeared. And now let's compute our position. And to do that, I'm going to create a local X, which means this is going to be only available in the draw function. And I'll say CX plus R, and then we'll multiply that. Oops, that's asterisk. Multiply that by our cos and our angle. And we'll do the same thing with our local Y, which is equal to RCY plus R, which is our vertical component, multiplied by cos angle, like that. And then we're going to draw our circle. So let's just say draw circle. Now to draw a circle, we're going to use the PICO-8 built-in function called the circ. So this is going to be our circ, and this will be our background circle, basically our point, our large point. So that's going to be CX, which is 64. For X position, CY, which is also 64. And our radius, which is 40, and the color, we'll use 7. And how do I know this? Well, if I use CLS to clear the screen, and I say help on circ, it tells us that we're drawing a circle at the X and Y position with a radius and a color. So that's what that X, Y, R, and color mean. Right. So now we have our circle. Let's draw our moving dot. So that's going to be a circ fill. That's going to be a filled circle. And we're going to draw that now at X position. Remember, X is going to be changing every frame. Same with Y. And we're going to draw the radius. We're going to set that to 2. And the color, we can select our colors in PICO-8. Each time you move over a color, we can see numbers at the bottom there. And I'll use color 10 here. So I'll set that to 10, like so. Right. So let's make sure we've ended this by closing it, and let's hit Control S and Control R. And now we can see we have a problem because our object is now oscillating at that weird angle. We wanted to create an angular velocity. Now we have an object that is not following that position. So let's go and see what the problem is. And so looking at the code, I believe I've seen where the error is coming from. And it's also important to use that to debug. At first, we thought it was our omega. It wasn't, but then we realized this is the problem here. So for our vertical component, it's supposed to be sine, not cos. And let's change this to sine. Save it and run. Now we can actually see that we have a white circle orbiting around, a white yellow circle orbiting around a position here. We can change this to say 4 to make this quite large. So if I run this, and what we can also do is to set our FPS to say 60 to give it a much more smoother speed like that. So that's how we can create circular motion using PICO-8. And you can use this to, when you're building a game, you can use this to represent like an object orbiting around. Now we can make the speed much more easier to control by adding some revolutions per second. And then we can, make that as part of omega. In fact, let's just add that upgrade. So I'll set this back to 30, and let's add a value for revolutions. So here, I'll just say revs, and I'll set that to 0.25 for our revolution. So now since this is in radians, I believe our PICO-8 uses radians for the angle, not degrees. So where we have our omega here, instead of using 1, we're going to use pi. So I'll just say revs and multiply that by 2 pi. So I'll put that in a bracket and do 2 multiplied by pi. So I'll just create the value for pi. I'll set that to 3.14159. So we'll just use that by 2 pi. So I'll just say 2 pi, like that. So let's save that. So now when we are using our omega, we can always change the value for revolutions. So instead of using 0.25, let's just run that. So we can see that. So let's change our revs to, let's say 0.5, save that and run. We can see now it's faster, right? So that's how we can use that to change it. And if we set that to 1, it's ultimately going to be spinning really haywire like that. So set that to 0.2. And we can actually see that's slowing down now. Let's set that to 0.02. That's going to be ultimately basically slow when it's moving. So that's how we can create a nice little program to check the circular motion for a parametric circle. Now, one thing I also want to point out about the revolutions is easier to think in revolutions per second. So we're converting our revolutions to second here to radians per second. So that's why we're multiplying this with 2 pi. So sorry if that's a bit confusing, but that's how PICO-8 works. All right, guys, thank you very much for watching. Hope you actually follow along and have fun, and see you guys in the next one.